maupun jurnalis masa depan. Lulus dari sini, kamu juga akan dibekali sertifikasi Junior PR dari Perhumas Indonesia atau Digital English Journalism dari The Jakarta Post. Di Prodi Hotel and Tourism Management, SGU bekerja sama dengan IMI Switzerland. Kamu bisa belajar langsung di negara yang terkenal dengan perhotelannya. Lulus dari sini, kamu bisa memiliki kesempatan menarik untuk berkarir di hotel berbintang maupun kapal pesiar. Ingin jadi manajer atau pemilik restoran? Kamu bisa mempelajarinya di International Culinary Business. SGU bekerja sama dengan IMI Switzerland. Nggak cuma belajar ilmu kuliner di Eropa, kamu juga akan mempelajari bagaimana cara menjalankan bisnis kuliner yang diajarkan langsung oleh para profesional di bidang ini. Fakultas terakhir adalah Faculty of Life Sciences and Technology. Berikut adalah pilihan program studinya. Pertama, Sustainable Energy and Environment. Kamu akan belajar untuk mencari tahu sumber energi alternatif bagi hidup berkelanjutan dengan memanfaatkan bahan makanan, energi, dan sumber daya air. Lulusan dari program ini bisa bekerja di sektor energi terbarukan maupun di perusahaan minyak, gas, atau perusahaan kimia. Kedua adalah Pharmaceutical Chemical Engineering. Kamu bisa mempelajari cara mendesain, mengoperasikan, dan mengoptimasi proses di industri farmasi. Saat lulus nanti, kamu bisa bekerja di perusahaan farmasi, kimia, dan perusahaan kosmetik juga loh. Ingin terlibat di bidang kesehatan, nggak melulu harus jadi dokter. Kamu bisa terjun di bidang Biomedical Engineering. SGU menyediakan program studi ini supaya kamu bisa menjadi orang di balik penemuan vaksin serta berbagai alat kesehatan yang dibutuhkan dunia. USG, laser, stetoskop, semuanya itu ciptaan para insinyur biomedis. Terakhir adalah Prodi Food Technology. Kamu akan belajar mulai dari cara memproses bahan makanan mentah sampai packaging serta penyimpanannya. Setelah lulus dari prodi ini, kamu dapat bekerja di industri makanan dan berkontribusi untuk menyediakan sumber makanan di Indonesia atau bahkan dunia. Mahasiswa SGU juga memiliki segudang prestasi, mulai dari prestasi akademik seperti beasiswa dari lembaga internasional dan juara dalam berbagai kompetisi, hingga prestasi non-akademik seperti olahraga, beauty pageant, dan sebagainya. Baik berkiprah di depan layar maupun di balik layar, berbagai alumni SGU kini menyebar dan terus berkontribusi bagi dunia. Banyak lulusan kami juga bekerja di perusahaan multinasional di dalam dan di luar negeri. Umumnya, setelah lulus dari SGU, alumni kami hanya perlu menunggu kurang lebih 1 bulan untuk mendapatkan pekerjaan. Malah ada juga yang sudah mendapatkan pekerjaan sebelum kelulusan. Berbicara tentang fasilitas, SGU punya berbagai lab yang bisa dimanfaatkan sesuai dengan program studimu. Untuk fasilitas olahraga, SGU punya lengkap banget. Kamu tinggal pilih jenis olahraga apa yang kamu suka. Untuk mendaftar, kamu bisa menuju ke link yang ada di description box dan mengikuti alur registrasinya aja ya. Oh iya, bagi kamu yang berprestasi, SGU juga menyediakan berbagai pilihan beasiswa up to 100% loh. Jadi kamu bisa banget memanfaatkan kelebihan ini. Jika masih ada yang belum jelas, kamu bisa langsung menghubungi hotline kami di 0811 80 10 600. Jangan lupa untuk follow akun Instagram kami di @swissgermanunit atau kunjungi sgu.ac.id untuk info lebih lanjut. Dalam beberapa tahun ke depan, persaingan di dunia kerja sudah pasti akan semakin ketat. Apalagi ditambah kondisi pandemi, tidak semua orang cukup beruntung untuk mendapatkan pekerjaan. Kamu akan bertemu dengan para saingan pencari kerja yang saling memperebutkan bangku di perusahaan. Di tengah-tengah ketidakpastian ini, kamu bisa melangkah dengan percaya diri di masa depan dengan gelar sarjana dari universitas dalam dan luar negeri, sertifikasi dari industri incaranmu, serta pengalaman kerja dengan para profesional di bidangnya. Pastikan untuk tidak salah melangkah and secure your future with Swiss German University. Terima kasih dan sampai jumpa di kampus.
Universiti Malaysia Sabah UMS dengan kerjasama Swiss German University SGU di Indonesia sedang menjalankan penyelidikan mengenai kaedah mengurangkan jangkitan penyakit tuberkulosis TB dalam usaha menangani peningkatan kritikal selain penularan penyakit TB di negeri ini. Kerjasama penyelidikan bernilai RM400,000 itu masing-masing mendapat pembiayaan geran sepadan UMS berjumlah RM200,000 dan RM200,000 daripada SGU bagi tempoh 2 tahun bermula tahun ini.
Menurut Pengarah Institut Penyelidikan Bioteknologi UMS, Dr. Zarina Amin, kerjasama ini hasil daripada pertemuan dalam Simposium Bioteknologi Antarabangsa Anjuran UMS tahun lalu.
Kami di UMS ada mempunyai makmal tahap 3 biokeselamatan tu kan, di mana kami boleh culture BSL-3 organisms yang macam TB tu dengan selamat. Inilah specialty of UMS. Kita sebenarnya perlu showcasekan yang UMS ni ada begitu banyak research facility dan research strength.
Beliau menyatakan perkara tersebut kepada pemberita selepas Simposium Bioteknologi Antarabangsa kali ke-6 Anjuran UMS dengan kerjasama Asian Federation of Biotechnology di Kota Kinabalu. Sementara itu, Timbalan Pengarah Kajian SGU Jakarta Indonesia, Dr. Kholis Abdul Rahim Audah memberitahu kerjasama antara kedua-dua pihak dalam projek ini melibatkan hasil bumi yang terdapat di Borneo seperti bakau yang berpotensi menjadi sumber perubatan.
So far we are in the process of extracting as many as possible the mangrove extracts, and later on we will test or screen all those extract towards tuberculosis and also as well as dengue viruses.
Mengenai
Program ini didanai oleh CStats, Sentra Community Service Fund dan Universitas University untuk benar-benar memberikan kontribusi dan support kepada UMKM yang terkena dampak akibat COVID ini. Salah satunya hari ini adalah menyelenggarakan program pelatihan secara online yang sebelumnya sudah didahului dengan kegiatan pelatihan secara online. Yang hari ini kebetulan fokus untuk praktikum bagaimana membuat batik dan kemudian tentu memasarkan batik ini ke segmen market yang tepat.
Sebagai salah satu penggerak UMKM di Kota Tangerang Selatan dan DPC Masata Kota Tangerang Selatan. Saat ini kami memberikan bimbingan kepada para pelaku usaha dari pendampingan Masata untuk memberikan pelajaran tentang teknologi batik dan pewarnaan. Kami optimis dalam memberikan pelatihan ini, para pelaku usaha pada masa pandemi ini bisa bergerak dan bisa melakukan aktivitas yang positif dan mengurangi daripada penerapan protokol kesehatan.
Saya mendapatkan banyaknya pengetahuan terkait dengan bagaimana proses suatu pembatikan.
Udah pulang. Udah lapar. Iya nak, Bunda masak bentar ya. Aduh. Masih kurang. Kurang apa ya?
Kelihatannya ribet banget, Bun.
Siapa kamu?
Nama saya Nyai Tumpi. Dan saya punya solusi buat Bunda. Risoya terbuat dari tempe fermentasi lanjutan dan rempah-rempah alami khas Indonesia. Pasti enak, Bun.
Instan begini? Emang bergizi di mananya?
Gak perlu khawatir, Bun. Risoya tentunya bergizi karena tempe itu rendah lemak, mengandung protein tinggi dan juga kalsium yang baik untuk tumbuh kembang anak.
Praktis. Nah, ini baru pas.
Makanya Risoya pilihan Ibu Bijak.
Hello, welcome back to the afternoon session of SGU Symposium 2021 with the theme of Achieving Competitive Advantage for Business Turnaround through Innovation During and Post-Pandemic Era. For this session, we will have an invited speaker Professor Dominik and Pak Harya Damar. Good afternoon, Professor Dominik and Pak Harya Damar, fellow lecturers and beloved student. I am Triarti Saraswati and I will be as a chair for this afternoon session. This session will be open with our invited speaker, that will be Professor Dominik Aufderheide and Pak Harya Damar Widiputra, and will be followed by 6 internal researchers that will be disseminate their research project this afternoon. For invited speaker session, the speaker will present for 20 minutes and then will be continued with the internal researchers. The session will begin with Professor Dominik Aufderheide from Sudwestfalen University of Applied Science. And before I invite Professor Dominik, I will read a brief curriculum vitae from Professor Dominik. Currently, Professor Dominik is a professor for industrial metrology in Sudwestfalen University of Applied Science, SUS, Germany. His academic career in automation, sensor technology, and industrial measurement and signal and measurement processing. He graduated as electrical engineer from Sudwestfalen University of Applied Sciences and hold master degree from the same university, and then got his doctoral degree from University of Bolton, United Kingdom. Professor Dominik involved in various board and committee, and since 2014 involved in various funded research projects. And hundreds of publications has been published from conference proceeding, journals, and chapters in book. So I will welcome Professor Dominik. Hello, Professor Dominik. Please come to the store.
Yeah, thank you very much for the nice introduction, Triatri. Thank you very much. It's a great pleasure to be here. And yeah, I think we can immediately start. Okay. Yeah, so welcome and greetings from Germany. As usual, we have again a rainy summer day today, as usual in Germany. And I would like to speak today about the visual inertial sensor fusion for 3D scene reconstruction. So mainly it's a topic from computer vision. And of course, I would like to invite all the audience members, if you have any questions, just put your questions to the chat or wherever you can reach me. So what I'm going to tell you is today a short introduction into the topic of how we can actually reconstruct a real scene just by using camera images. And for this, I would mainly give an introduction, first of all, about the general topic. We'll then talk about visual inertial parallel fusion network, because we are going to achieve this final goal of reconstructing a real scene by using sensor fusion approach. And we have basically 2 different kind of fusion networks. One is the visual inertial fusion network. The other one is what we call an extended fusion network, which is based also on range sensors. And I will also show very briefly a short case study how we actually used it in order to achieve a reverse engineering approach. And finally, I will conclude my talk. So starting with the introduction, as you all know, there is a high demand for the creation of 3D models from specific real-world objects or scenes. Typical applications fields, I just named 3 here on my slides. For example, in the field of mechanical damage analysis, where it is important, for example, if we see some specific part, okay, it is deformed, something had happened in the past, and we want to know what happened, and probably we want also to see what are the causes of that damage. The same for diagnostics. As you all know, in Germany, we have a quite huge amount of suppliers and manufacturers of cars and automotive components, and there it is also very, very interesting to run diagnosis on specific 3D cases. And then, of course, the field of reverse engineering, which I will later show in my case study also. So that means reverse engineering, if I do not have any, 3D, for example, drawing of a specific object, but I want to capture the drawing from the actual object by using these kind of techniques. So unfortunately, due to the fact that there is a high demand for 3D models, the problem is that even today, scanners which are able to deliver 3D models from real-world objects, for example, laser scanners or specific structured light scanners and stuff like that, are still quite expensive to buy. So just that you have some figures in mind, if you want to buy a good, even handheld 3D scanner, you can easily pay an amount of 30,000 euros or something like that. So 30,000 euros, $40,000, that is roughly what you need to spend if you want to have a good scanner with a good accuracy. So that is the problem why, even if there is a high demand, a lot of especially small and mid-sized companies are not so eager to use this kind of technology because it is quite expensive yet still to actually use these kind of scanners. So that's why we have one idea where we said, okay, we want to come up with a solution which allows that we have, low price sensor which we can use to capture a real world object. And in order to achieve that, we had, the final goal in mind. Okay, so for example, we all have our smartphones, and the smartphones are equipped with a specific set of sensors altogether. So for example, all the smartphones are equipped with cameras, and therefore our standard idea was, okay, let's just use a standard camera in order to capture a 3D model of a specific object. And for this, we want to utilize an approach which is, even described in literature for decades, which is the structure from motion approach. I would just give you a short introduction how this works. So let's assume we have any kind of 3D object or scene we want to actually capture, we want to get a 3D model of. The idea of the structure from motion process is, okay, if we are moving a standard camera around this object and we capture images from different perspectives of the same object, and we do this continuously throughout a video sequence, it is possible that when we are able to track so-called points of interest, what we also call future points, throughout the sequence, which means that we detect those features and we are able to match those features in all the images so that we see, okay, this pixel corresponds always to the same physical point, and we find this same physical point in all the images. It is possible to compute from this point information a 3D model of the object and to estimate also the motion of the camera. So here you see an example. These are all the feature points which we captured, which we tracked throughout the sequence. And later on, we are able to actually reconstruct the three-dimensional structure of the scene of these feature points. This approach is called structure from motion. And as said, it is described in literature for decades, but in the days before today, we actually do not have really the computing power, especially not on mobile devices, to really do it. It was more like a theoretical approach, and it was more like an approach which you can just compute offline. The problem with this approach is, okay, we could basically use it, but because it would actually require no special hardware, just a standard camera, it would be the low-cost solution we were looking at. But there is one problem, because this feature matching and the feature tracking throughout the sequence is an unstable problem by nature, which means that it sounds easy, find the same point again and again and again in all the images of the sequence, but it is very, very complicated to do so in reality due to effects of perspective distortion, illumination, and stuff like that. It is really, really not so easy to do that. So here came our idea, okay, why not use a sensor fusion approach? And our idea was, okay, within our mobile phones, we also do have a second set of sensors, which are inertial sensors. Inertial sensors, for those who are not familiar with these kind of sensors, are sensors which capture actually the motion of the object. For example, in order to achieve the functionality that the screen is shifting when you swap your mobile phone. So these are sensors like accelerometers, gyroscopes, and stuff like that. And these are also included in any kind of mobile phone. So in order to fuse the different kind and pieces of information, we came up with what we call the parallel fusion network. And the architecture looks like this. So on the one hand side, we have the camera and we have a visual fusion cell, which means this is basically an implementation of the structure from motion algorithm I've showed you earlier. And then we have a second set of sensors, the inertial sensors. And in our case, we work with 3-axis magnetometers, accelerometers, and gyroscopes. Why we need 3 axes? Of course, since we want to capture the motion in 3D, we always need to have 3 axes, x, y, z coordinate and the associated angular velocities we are looking at. And these are actually computed in an inertial fusion cell. And this inertial fusion cell is able to compute a second piece of information, also the motion. And then you see one of the major aspects of sensor fusion. We have the same information, in our case, the motion information, from 2 different information sources. And then it would be possible to fuse this kind of information in a visual inertial fusion cell to have an enhanced result at the end. So when we look at these architecture, okay, the visual fusion cell we already captured. We also already said, okay, that is basically structure for motion, which is actually implemented there. So let us talk about the inertial fusion cell a bit. The inertial fusion cell is actually an implementation of basically a standard inertial navigation algorithm. I just want to give you a short insight on how these kind of inertial information algorithm works. So for example, if you have gyroscopes, 3-axis gyroscopes, these kind of sensors, they are able to bring you angular velocities around the different axes. So if you have angular velocities and you want to have what is the orientation of the device in a 3-dimensional space, of course, you know, when you have velocity, okay, what we need to do is that we need to integrate the velocity in order to get the absolute orientation in terms of an angle in 3-dimensional space. So sounds very easy. And you can do the same for accelerometers where you measure acceleration. So you need to do a double integration to get the actual position in a 3-dimensional space. Sounds very easy, but there is one big problem with these inertial measurements because they are very, very noisy. So that means that when you're actually not moving your phone, your sensor, they will still deliver you some noise. And if you're integrating, usually you have some kind of a drifting behavior, some kind of an unbounded drifting behavior. So that means that, okay, inertial sensors are also quite sensitive to noise and also quite, could be quite faulty from the readings. So that is the problem we need to actually use. And what we did is that we implement in our inertial navigation and inertial fusion cell a bank of Kalman filters. Kalman filters, if you're not familiar with that, are basically one of the methodologies where you can actually fuse different pieces of information captured from different sensors, and you know that all of these sensors are actually deliver a measurement with a certain uncertainty. And if you actually can estimate the uncertainty of the readings, it is possible within the Kalman filter to get an update of your prediction, and therefore you improve the overall result. Just, very basic idea of the Kalman filter. And with this bank of Kalman filters, we are able to deliver kind of a motion estimation, which is much more stable than without the Kalman filters. Okay, so that means now we have motion and structure from the visual side, and we have motion from the inertial side. And now, of course, we need to have some kind of methodology how we can fuse these different kinds and pieces of information. And there we need to have a short look into the visual inertial fusion cell. And I will just give you one example how these pieces of information are used. As we already said, the biggest problem in acquiring the 3-dimensional model of the object is that the feature tracking, so as you remember, the tracking of those red points in the images is unstable due to occlusions, motion blur, and all the different possibilities you could have where you can lose track of a point. So I just want to talk about how we use now the inertial information for the motion in order to get rid of some of the problems of feature tracking. And for this, I would like to showcase, okay, how is a feature point typically rematched and tracked throughout the sequence. So let us assume we have this red point here in an image and we want to find it again in a second image. What we do is that, okay, let's look on the neighborhood around this red point. So here's the red point, and that would be the neighborhood of the red point in an image. And now assume, okay, we want to find the same red point again in a second image. And of course, if you look on the neighborhood appearance will have changed due to the fact that the camera has moved. So what we've done is that we implemented an approach where the patch, the neighborhood, is transformed by what we call an affine photometric warp. And this affine photometric warp actually uses the information of the motion of the camera in order to estimate what would be the appearance of the neighborhood in the next image. So that means that this transformation is able to compensate the changes of the neighborhood due to the camera movement by a so-called affine transformation. And it is able to actually compensate the difference due to the illumination, due to a photometric model, which we have included in the transformation equation. And that means, of course, if we are able to pre-warp, pre-transform the neighborhood in order to find the point, the result will be much better actually to implement that. And that is the idea of what we call VIF track, visual inertial feature tracking, so to say. Okay, so inertial motion can be used to estimate affine transformation parameters. So let us now check the results of this approach, and I would like to show you a comparison, the results without using inertial measurements, so pure, let's say, visual measurement on the left-hand side, and on the right-hand side, we can see the results with inertial measurements. So if we are looking on the results without inertial measurements, what you can see is, okay, all the red dots, as soon as I start to move the camera a little bit faster, we are more or less losing all of the points, as you can see. If I'm moving slowly, it's okay, but if I'm moving faster, I'm losing all the points. And now I will show you in comparison the result with the new approach. And what you can see is that now the feature tracking is much more stable due to the fact that we have a second piece of information for the motion estimation. So we will not lose any kind of feature points. In white, what you can see in white are the movement vectors between two different frames. And what you see is that now the feature tracking is much more stable. So this is one of the results where we use the sensor fusion approach. So if we are using this approach, of course, we tested with a lot of different objects. And of course, our final goal was a 3D reconstruction. And this is what we actually achieved here. Yeah, so this is a 3D reconstruction of this object here. And you see that, okay, we have some 3D information, but it's still not really nice. Yeah, because you see it's quite a sparse representation of the object we have. The 3D reconstruction accuracy is good, but we have a kind of sparse representation, so we are not so happy with this result, even if, of course, if it's much better with our approach. So therefore, I would like to talk very briefly about the extended fusion network, where we implemented now range sensors. These range or RGBD sensors are specific sensors which are able to deliver you a depth measurement. And this is the only specific sensor we need to add. The good thing is that these kind of sensors are also available now at very low cost. So around 200, 300 euros, you get a good RGBD sensor. And these sensors deliver you a color image of the scene and a depth representation. And we included that in our extended fusion cell, where we have the inertial fusion cell, the visual cell, as discussed before. But now we have an additional range fusion cell, which we added in order to have a more dense representation of the scene. And here you see one example which we were able to achieve by using this kind of approach. This is now a really dense representation which we have. This is now a representation where the actual reconstruction error is in good limits. Of course, we're still working on getting it a little bit better. But this is now a 3D scan, which we basically captured with a sensor setup where the complete hardware costs are below 500 euros. And of course, you can also use it not just for small objects, but for complete scenes where you get, complete 3D reconstruction of a complete scenery. As you see here, all of this works in real time. Here you see now that the sensor setup is moved along a scene, and the 3D reconstruction will appear in real time. You do not have to have any offline processing. It happens immediately. That is what you can see here. And of course, as you move the camera along, the representation of the scene will get much better, and you're even also able to capture large-scale scenes. Okay, short case study. For what purpose can this approach be used? We have one project partner here nearby, which is one of the world leading suppliers of components for car racing. So I'm not so sure if Formula One is big in Indonesia, but probably you have seen Formula One cars, and this company, for example, delivers a lot of components for Formula One cars. For example, this halo safety mechanism is manufactured and developed by this company. And they were interested to have the possibility to capture directly on the car three-dimensional models of specific elements, because due to the fact that they want to come up with specific CAD designs which they do not have in stock. They need to capture from the real-world object. And that is what we actually done in the reverse engineering case study. We worked closely together with them in order to actually check, is it possible by using this low-cost new sensor, 500, 600 euros, capture the scene, derive real CAD data, which they can actually use to design new components. And we were actually able to achieve that with quite a good accuracy, and they are still now using this kind of technique in their daily life. Okay, I think that's more or less it. Let us conclude what we have spoken about. So the achievements: the visual inertial sensor fusion is able to outperform classical structure from motion in terms of accuracy and, of course, applicability. But nevertheless, we have seen it's still just a sparse scene representation. So if we integrate range sensors, we are able to use to get also a dense scene representation, and that, of course, would improve the applicability and the robustness. And of course, the case study showed just the enormous potential of the WISREC approach, even for real-world applications. And as I said, it is still in use today in that specific company. Okay, I think that's it. And of course, I'm open for any kind of additional questions. Thank you very much for your attention. It was a great pleasure to speak here. If you have any questions, just let me know.
Thank you, Professor Dominik, for the interesting presentation. But unfortunately, we don't have time for discussion. So if the participant willing to ask something to Professor Dominik, you can put it in chat room, and then the committee will deliver it to Professor Dominik. Thank you, Professor.
Thank you very much.
Okay, next we have Pak Dr. Insinyur Harya Damar Widiputra from PERBANAS University. And I will read a brief curriculum vitae from Pak Harya. Pak Harya has a lot of experience as lecturer in university. Years ago, Pak Harya also as a lecturer in SGU, and Pak Harya also has experience as lecturer in Auckland University of Technology in New Zealand, Lang Lang Buana University, Telkom University, and PERBANAS Institute until now. And currently, Pak Harya appointed as Vice Rector Academic PERBANAS Institute. He holds Professional Engineer Certification or Insinyur Professional Madya or IPM. Pak Harya research interest in computational intelligence, machine learning, data mining, decision support system, business intelligence, evolving connectionist system, pattern recognition, and else. And Pak Harya Damar also received a lot of awards and research grant with a lot of experience in community service and industry. And he also has a lot of publication that published in conference proceeding, journals, book chapters, and book. And also hold copyright in computer program in nonlinear localized trend model. So I will welcome Pak Harya Damar Widiputra for the presentation.
Thank you very much, Bu Triarti, and good afternoon to everyone. It's always been a pleasure to join SGU event, in particular this symposium. And thank you also for Professor Dominik for a very interesting talk. I think I'm going to be quite fast, so maybe later on, if we still have time, and if some participants have questions for Professor Dominik, maybe we still have time, Bu Triarti. So I will just start directly. Okay. Okay. So my research area is mainly in the area of time series analysis and modeling. So just would like to share what I've done lately regarding the time series prediction. Time series analysis and modeling, which is the objective is to conduct a prediction of a time series movement in the future. Okay, so time series prediction has always been a very interesting topic. It's challenging. Some people believe that it is not possible for us to really predict the future, but actually by looking at the past events, there's a huge possibility that we can extract some knowledge based on recurring patterns, and then we can use it for prediction. Okay, now the main problem is what I'm interested in is not only about getting the most accurate prediction, but it is more about extracting knowledge that can actually help us to understand better the nature of relationship between multiple variables in a set of time series data. So mainly my research focus is in the area of dealing with multiple time series data. Means that we are using a set of variables that are interconnected or interrelated to each other in a single dynamic system, and then try to learn more about their patterns of interaction. And then afterward, we expect that by being able to do so, then we should also be able to predict the behavior in the future. Okay, so I'm lastly I've explored the area of using neuro-fuzzy inference systems. So it's a neuro-fuzzy inference system base, but we apply this in the area of transductive learning. Means that we don't actually train a single model. So transductive learning is quite different in comparison to inductive learning or inductive reasoning, which is usually we train a single model and then we use it. This is what happened with a basic neural network architecture. But with transductive, we don't really have a single model. But every time we have a new problems that we will search through the domain space to the sample set and find the most relevant or most informative samples that we can use to then build a new model that can help us to solve the problem. So why we'd like to explore the usage of transductive reasoning in this case, because we believe that the nature of movement of a time series data is keep changing from time to time. So if we train only a single model and then we use it every time, soon enough, it will be obsolete. Means that you have to retrain your model again and again, and it will be costly. So means that we want to have an adaptive model, and one option to be able to do this is by incorporating transductive reasoning. Okay, so the background, as I explained earlier, it's about most people are trying to do time series prediction using a single variable analysis or a univariate analysis. Means that we predict a single value based on the past value of that variable itself. But we are interested in building comprehensive patterns of interrelationship between variables. That's why we are working with multiple data sets. And then would like also to extract complex patterns of relationship and model them in human readable form. Then again, as I mentioned earlier, we interested not only to be able to predict future value with high accuracy, but we want to be able to extract knowledge as well. So if you use a standard, we know that multiple linear perceptrons, or maybe convolutional neural network, or maybe LSTM, or the combination of both, we use deep learning, we can really achieve a high accuracy of time series prediction. But then again, it's still a black box. You don't really have extra knowledge about why the results is so. Yeah, you don't really have an additional knowledge that can help us to understand better the nature of the dynamic system itself. Now, this is the main reason why we go through the neural-fuzzy inference system, because with neural-fuzzy inference system means that there's a process where we construct a fuzzy rules, and then this fuzzy rules is actually giving us a new knowledge about the relationship of multiple variables. So that's another benefit or another objective that we want to achieve, not only being able to predict the future value with good accuracy, but also would like to be able to extract knowledge about patterns of relationship. Okay, so our research objective is to actually, this algorithm has been proposed before. So we have developed this algorithm maybe a couple years ago, and then we would like to revisit and then make some adjustment or development to the algorithm so it can give better insights basically about the fuzzy rule that it is extracted from. And then our main research question is actually, would a transductive model provide a specific and better local generalization compared to methods of inductive inference? Then again, by using a transductive model or transductive reasoning, we expect to have a better specific model for every or for each problems that we're going to solve. And then we also will be comparing the results, the experiment results, with some more prominent or more widely used or widely known time series prediction algorithm, which is the standard multiple linear regression, and then multiple linear perceptron and other algorithm. So this is what I've mentioned earlier about the transductive reasoning model. Most of the time series algorithm works based on the inductive reasoning. Means that again, you give the algorithm a set of training set data, and then the algorithm is trained using the training set data. Once you have a stable model, and then you use this model to the test data, or maybe for the real case, you predict the future based on this single model. And then, unlike this inductive reasoning, the transductive reasoning works by approximating the value of a likely model only for a single point of space by exploiting supplementary evidence related to that factor. So it means that we have a new problems, and then we will search through the problem domains and then find the most relevant sample to build the model. Transductive reasoning presents some benefits, therefore, which is actually it only utilizes some parts of the sample data set that is relevant to build a model. So let's say maybe we have 100 samples, then we won't be using all hundreds, but we will only be using those samples which are the most relevant to the current situation. And it will also may decrease the consequence of data anomalies or inaccurate recognition of sub-problems, because the basic nature of inductive reasoning is actually generalization, and because of this generalization, then means that there might be some inaccurate recognition of sub-problems. Yeah. Okay, so the algorithm is named the MTNFI, which is the multivariate transductive neural-fuzzy inference. Means that it's a neural-fuzzy inference systems working on the transductive setting and can be applied to a multivariate or multiple time series data set. And it works based on we're using the Takagi-Sugeno, the TS type of fuzzy rules, because it's quantitative. So the antecedent and the consequent part is based on the TS type of fuzzy rules. Okay. In this case, we are using the states of relationship between variables in a single time point, because we have several numbers of variables, because we're dealing with multiple time series data. And then the way we represent the states of relationship between variables in a single time point is calculated based on the ratio of first order rate of changes as this equation. So we actually calculate the changes of value between current time points and previous time points. And then we do another calculation about the ratio between each series. So this is actually, the formula is used to extract features. And this features matrix is the one that will be used to find the most similar condition in the past for us to build the fuzzy rule inference system that can be further on used for prediction. And then, as I mentioned before, the fuzzy rules set is TS type of fuzzy rules. So let's say if we have P variables, variable 1, variable 2, and so on and so forth until P variables, then we have a number of rules, a set of rules that contains and will serve for each of these variables. So basically, we'll end up, the algorithm will produce a huge number of fuzzy rules, which is actually for every single variables, we will get a single fuzzy rules. Then let's say if you have 10 variables in your dataset, in your time series dataset, and then you'll end up with 10 fuzzy rules. And these fuzzy rules, this set of fuzzy rules will be updated every time you want to make new prediction, because the dataset that is being used to construct the fuzzy rule will change as well. So this is the framework or the basic scheme of the algorithm. So let's say I have this is my time series dataset, and then let's say this is time t. So first of all, we will try we will extract the features of the time series at time t using this equation as I showed you before, and then we try to find similar condition in the past. Let's say maybe at time point 1, time point 2, and so on and so forth. Let's say we end up with finding 4 similar sample in the past that has the similar representation of features with current time points. Now, means that we are not going to use all the data set, but only we'll be using K samples, K found samples. So maybe some of you are familiar with KNN, K nearest neighbor. So basically, this is very similar to K nearest neighbor, because K nearest neighbor is a very straightforward transductive reasoning algorithm. So you try to find the most similar condition in the past, and then use only those samples to construct a fuzzy rules set, a fuzzy rules that then we will be using to construct our fuzzy inference systems. Now, once the sample is found, and then we cluster the samples. So let's say we found K samples in the past, and then we run the evolving clustering method, which can be used to cluster these samples, to further cluster the samples, and the fuzzy rules will be constructed for each set of this, for each clusters that has been created. So let's say maybe from this case sample, we end up with 5 clusters, and fuzzy rules is then being constructed for every clusters. This is where the neurofuzzy inference, the neurofuzzy terms takes its function. Okay, so these clusters will actually represent neuro. Yeah. So it's quite maybe similar and further with the neural network, but instead of using a hidden neuron, the neuron itself is being represented by clusters of samples. And then we optimize this using a backpropagation algorithm, and then we'll end up with a stable and optimized fuzzy rules that we will be using to predict the future value. Okay, so we go to the experiment part. Because we are trying to assess the algorithm first, we haven't tried this using real world data, but we generate our own synthetic data set, and then we evaluate this algorithm using this synthetic data set. The synthetic data set that we constructed consists of 4 different series that are interrelated and trajecting simultaneously. Then the evaluation method that we're going to use is we are going to identify a number of created rules that will be used to generate the fuzzy inference systems. And then we also would like to check whether the created fuzzy rules is possible by comparing the extracted rules with the nature of the synthetic dataset that we created. And then the last one is to examine the prediction accuracy level calculated by the fuzzy inference system. So still, we also have an interest in whether the rules, the extracted rules, is capable of producing a high accuracy prediction for the time series itself. Okay, so this is our synthetic dataset. As I mentioned earlier, it's consisting of 4 different series. And actually, the way we constructed this, each series is interrelated. So series 2 is a function based on series 1, and then series 3 is also a function based on series 1 and series 2, and series 4 is a function based on series 1, series 2, and series 3. So somehow there's a hidden intercorrelation between these 4 series. Means that you can actually predict the movement of series 4 using values of series 1, series 2, and series 3, and so on and so forth. Now, we try to run the algorithm for that particular synthetic data set, and then we end up by so here, let me check. Okay, so this is there's a black line here. So we try to construct the fuzzy rules for the last 15 time points, starting from time points 36 to 50. So there are 15 time points, and then the search space to create the fuzzy rules starting from time point 1 to time point 35. So the number of created rules for the last 15 time points is actually for time point 1 means time point 1 here is time point 36 in the image, because time point 36 is the first time points for our testing set. So this is actually time point 36. For time point 1, 4, 6, 7, 12, 13, and 15, we have only 2 created rules, means that the movement is quite stable. There are only 2 different types of movement being recognized by the algorithm. And then for time point 2, 3, 9, 10, and 14, we have 3 created rules, and 5, 8, 11, we have 4 created rules. So this actually indicates that time point 5, 8, and 11 is more volatile, and therefore the number of created rules is also higher than the other 2 time points. So we can actually see that the MT-NFI creates unique sets of fuzzy rules to construct the inference system for every new input vector. And when predicting movement of the 15 time movements of the test dataset, it creates different 15 fuzzy inference systems. So that's what I mean. We don't have a single model, but when you're predicting 15 time points, then you will end up with 15 model actually, or in this case, it's 15 fuzzy inference systems. And every inference system contains a different number of fuzzy rules depending on the results of the clustering process, as I mentioned earlier. This is an example of 2 created fuzzy rules when predicting the movement of time points 15. So the first rules is, this is the rules. As you are maybe familiar with fuzzy rules, there's always antecedent part and then the consequent parts. So the antecedent part of rule 1 is if the ratio of difference between series 1 and series 2 at time point t is Gaussian membership this, yeah, and ratio of difference of series 1 and series 3 is Gaussian membership with this value, and so on and so forth, then the algorithm will calculate the next value of series 1 is actually 1.358 times current value of series 1 minus 0.163 times current value of series 2, and so on and so forth. Now, this is what we actually expect to have. So the algorithm is not only producing final value, but also describe how the final value is being calculated. Okay, so
excuse me, Pak Harya, the time is almost up.
Yep. Okay. So this is actually just illustration about the comparison between the actual value and our algorithm, the anti-MFI, being compared to multiple linear regression and then multi-layer perceptron and other algorithm, which is Danvers and random walk. We can actually see that the trajectory, the predicted trajectory, is quite close based on produced by the anti-MFI. Then you can see also based on the RMSE, it's the same value actually. And we can actually see about the number of K because it's transductive reasoning. The number of K is also very important. And then we can see that the number of K is quite stable for 20 nearest neighbor is found. And then it will produce the lowest RMSE. Okay, so that's bring us to the conclusion. So far, we can see that the MTNFI is proven to provide a specific and better local generalization, and the algorithm is able to produce human readable form rules. Yeah, that can help us to understand better the nature of the dynamic system, and it can also produce a quite accurate prediction using our synthetic data set. And then for future works, of course, we would like to explore how if the algorithm is being applied to real world data. So now currently we are in the step of using the Google mobility dataset to check whether this algorithm is capable of predicting movement of people during this pandemic event. And then we also would like to incorporate non-linear modeling analysis into the algorithm. So we expect it to increase the performance of the algorithm. Okay, so thank you. That's all that I can share about our last work. Thank you very much, and sorry for taking more time.
Thank you, Pak Harya. So for the participant, if you are willing to have question for Professor Dominik or Pak Harya, you can drop the question in the form that provided by the committee in the chat room. Okay, next we will have the dissemination from the research of in engineering field. And now Pak Heru Purnomo Ipung will have a presentation of his research project. And then for Pak Heru, please, you have only 8 minutes to present your work, and then the later 7 minutes to question and answer. Please welcome Pak Heru Purnomo Ipung.
Okay, thank you. Can anyone hear? Okay.
Yes.
Yeah. I'm going to show the presentation. Okay. Why is not now? Okay, actually, my exploration is actually on the AI in area of learning, but it's focused on the visual context understanding. Is actually so yeah, the focus actually on the software architecture. So what will be the combination of a component and tools is put in place to do that. Initially, it's actually for education, but I found out this. We found that actually this one can be immediately used for others industry. So then is in the middle of the exploration, we change course to the others area. So okay, this is about knowledge graph. Knowledge graph is being used to find talent. It's already Dex is a text-based, so it's natural language processing and others. But I'm going to apply this one and combine this one with visual learning here. So this is the framework that I propose is actually. So there is a knowledge base, and then there is an image model. This one is need to be analyzed to have an understanding. For example, like I give you the picture, what will be the context of this picture? I am currently computer vision is actually on the certain object, looking for a certain object, but it's not the combination of object within the picture. So it's a combination of a knowledge graph and knowledge base and graph with image understanding. So for example, like this, if there is a picture like this, there is several components identified like a microwave and then oven and others. So what is actually what is the picture all about? So it's supposed to be for a kindergarten of a primary student. It will say, well, this is a kitchen. So this one is actually something that's the purpose of this one. Context identification or understanding on the picture. So yeah, I'm commenting like something like the already in place like YOLO. That is for identification object, but this is only for explicit object, but implicit object or knowledge is not yet mature on this one. So it's for example like this one is within the within the image of object and others. Text mining itself is mature. Knowledge graph is maturing as well, but I'm combining it with visual learning. So this is my proof of concept, given the visual image, and then we do the processing and extracting what is other object within the visual the image. It's one ball, 3 chair, 1 potted plant, and others. So it's detected. Then we have a reference model, which is knowledge base. What is described as a home? Home is consists of bedroom and others. Bedroom is consists of others and other and etc. So that's example of a reference that we build, and then we do some network analysis on this one, extracting all of them, and then what is the position of those. This is actually the tool is already established, so I just use that. Then is doing the connection of those, as well as the non-extraction of this the contact itself, either the picture as well as the knowledge graph, and then we need to link all those paragraph and sentence accordingly to the key nouns or object that's actually is already there. So that is the idea of linking understanding of what is the context of this. So it's at the end the system will say, okay, this is a kitchen. So that is the idea. But further research is actually I'm directing it to agriculture based. This is it's based on my previous research as well in the area of agriculture. So this is the example that I've been working for in the past 3 months. If you look at the Agri-IoT frameworks, if you look at the device plan, there is a context tracker, and then in data analytic planes, there is an event in detection. This is the whole framework of Agri-IoT framework, which is those visual context understanding can be applied to this one. For example, like if there is one picture, like number 1, this is what will be the context of this one. The context will be this is the plant is chili, and then what happened with this one? If you look at number 3, there is a certain leaf. There is a spot, yellow and black spot. So what does it mean? So that is actually related to data analytics, event detection. So if there is one spot here in leaf with the context of this is the chili plantation, so then it's combined with a knowledge base of the agriculture about the health of the plant health and others, as well as the understanding of a plant itself. Like for example, like this chili is different with different kind of other plant, and then what happened with this one, like a number, the picture number 3. So I'm still building it at the end of the day. So it's going to be input into the number 4, 5, and 6. This is actually kind of my experiment on the intelligent automation of agriculture. When there is I'm going to, the plan is I put one plan here, and then it's automatically it's going to be the system is going to put if there is a indication of a certain health problem, then it's what's going to be done without minimal intervention of a human. So that is that's the idea.
Excuse me, Pak Ipung, can you speed up the presentation?
Okay.
Because time is
so
up.
that is that is the one of the application of this and this one that I'm still working on. Paper has been drafted and submitted. Is a novel computer vision to combine algorithm for context understanding or certain collection of object within an image. So that is with combining the knowledge base and knowledge graph with text and image. I think that's about it, Bu Triarti.
Okay, thank you, Pak Ipung, for the presentation. Now I will invite Professor Dominik as reviewer to give question to Pak Heru Purnomo Ipung, please.
Seems that Professor Dominik has left
the meeting. Okay.
Yeah.
So maybe Pak Harya will ask the question for.
Okay, Pak.
Oh, means that the single filer or single reviewer. Oh my. Thanks. Thank you, Pak Ipung, for the presentation. So may I know? Can we go to the slide after this one? The last slide, I think. This one. Okay. Can you explain further about the object detection analysis? What kind of algorithm do you use to detect what kind of object this is?
Okay. Actually, I'm using the latest computer vision algorithm. Is YOLO 5. It's been around. Is early 2020. 21st, that is more accurate than others, but still have some issues for this one. So it's that's to identify something like this. So using this YOLO 5, that is going to extract what will be all the object within the picture. So like if you look at the bottom, it's identify one ball, 3 chairs, one potted plant, one bagawak, and others. So that is from this, and then we have something like knowledge base on the what is home all about. So there is a reference for this one, that is extracting all the nouns and others. So it's for example, like simple description of home, what is home all about, and then we extract all of them, all the connection, and then we extract all the nouns. then we look at all the connection within the sentence. So that is so the system can identify because there are this certain indication of object. That means it's mostly this is a picture of kitchen, for example. So that is the architecture of this one. But this one can be applied for something like this. So even though the challenge is actually on the vision algorithm itself, YOLO 5 is not yet identify the variation of leaf, for example. So we need to develop further training data set to understand several shape of leaf, flowers, and others. So that is the challenge, but this is just a novel approach. It's just the architecture. Further is we need to develop, collect all the data set for trainings to understand the specific knowledge base like this one. The knowledge base of the plant health is actually there. It's already complete. There is an expert system for this one, but that is actually still manual, right? So people still need to identify. Okay, this plant has certain symptoms here, and then inputting in that expert system, then that will be the suggestion. So the idea is actually by just presenting the picture, then the system itself can identify certain symptoms, and then the context of this, and then combine with this knowledge base. So that is the idea, Pak. Yeah.
Okay, thank you, Pak Ipung. Bu Triarti, is time is up or?
The time is up.
Okay.
So thank you, Pak Harya and Pak Ipung. We will go to the next presenter. I will invite Pak Leonard Rusli.
Okay, thank you, Bu.
Okay.
Terima kasih Bu Triarti. Untuk presentasi tim saya akan dibawakan oleh Chris dan Pak Rusman, cuman mainly Chris. Silakan Chris, mungkin bisa dimulai.
Thank you, Pak Leo. I will share screen my. Okay, can you see my share screen?
Yeah.
Okay.
Yes.
Good evening and good day, everyone. Thank you for the opportunity to present the result from our research group on autonomous mobile robot at Mechatronics Department. It is funded by RCS via CSF or Central Commodity Service Fund. My name is Nova Christian and I am project engineer, especially on electronic and algorithm. We have here Leonard Rusli, Ph.D, as our project leader and mechanical design and calculation. Dr. Rusman Rusyadi as our head of research on algorithm and computer science, and also Johannes Freddy as project engineer on mechanical design and manufacture. Today I will present about disinfectant robot with far UVC and autonomous navigation in indoor usage. This first stepping stone to build more robust and more general purpose autonomous mobile robot. Okay, first of all, this is the outline of the presentation today. We will start with research background.
Sorry, but
yeah.
In my at my site it doesn't change. I'm still looking at the PowerPoint. Maybe.
Sorry. We'll share screen once more.
I will remind you, Chris, you have only around 8 minutes to present your work. Okay.
Okay. Can you see?
Yeah. Okay.
It's good now. Okay.
Okay. This outline. Okay. Design a system overview result, and we will see video of our result research. Okay. Research background. We believe that human life is precious, and any harm to human health must be reduced or avoided. We can see from the left picture, we see that the old way we disinfect the room are inefficient and dangerous for the personnel. On the potential of infection, also hazardousness of disinfectant liquid for the personnel. In the other hand, we have more safe and more efficient method to sterilize the equipment in hospital using ultraviolet light. With those knowledge, we propose a new method to increase the safety and efficiency for disinfectant process. Okay, our new method has several objectives, such as first, develop autonomous navigation system algorithm for indoor usage based on LiDAR, camera, and odometer sensor. Second is build a safe, robust, and good aesthetic mechanical robot design. Third, implement the UVC or far disinfectant to the robot. And the last is implement graphic user face and integrate it with RVs. Okay, before we dive into autonomous mobile robot, we should know the difference between AGV or automated guided vehicle versus autonomous mobile robot. We can see the AGV in the left picture and the AMR in the right picture. The main focus, the difference technology is the nature of technology itself. For AGV, it needs to follow fixed route. Usually use magnetic stripe line strip, and accelerator. Because of that, it's not very adaptive to its surrounding changes. In other hand, AMR it's not needed to follow fixed route. You can follow and adapt surrounding changes. To do that, AGV will have more expensive treatment because it needs to prepare to environment first. But for AMR, it should not be much changes for current technology. And this is what I said before. And this is our design. Here is our prototype mechanical design that already made. We can see here we have LED screen, also to represent the robot status. We have the UV light and emergency button. And here is the system overview. We start with mapping the environment using SLAM method. This step can be skipped if we have a map of the room. Otherwise, the mapping process will generate a 2D map and will be used for navigation. After we have a 2D map, we can set the goal, the robot, and the robot will generate path planning and moving the robot based on the path planning that has been generated. After the robot achieves the goal, the robot will stand by with a new goal. We will talk about the testing and result. Here is the LiDAR result. We can see here from this testing, we know that LiDAR cannot detect the transparent object. Because of that, we adding ultrasonic sensor to detect transparent object. And here is our mechanical result taken from poster from our industrial partner map. We can see here the LiDAR is placed on the top of the robot. We have also stereo camera to help to identify obstacle and also to help for obstacle avoidance. We have also ultrasonic that is in the below. We use it to detect a transparent object. And there is a UI result. There are two UI that we use. First UI is for engineer side. It's called RVs in the right. And the other one is our UI design for non-engineer in the left. We can see later in the video how those UI will contribute on the robot. And here is the mapping result of two different places. Left is in the workshop and the right picture is in the SGU lobby. We can see that there are some outlier. I call it outlier. It is because they are placed in there, and as I said before, LiDAR cannot detect transparent object. And here is our prototype result. I will make it fast. Okay, we can see here how our UI will be used. It can be used without the RVs, but the UI that we made will simplify the operator to operate the robot with only 2 or 3 clicks. In here, I use Here I use a scheduling point with 3 point stopping area. Okay, stopping area. When the robot is reached the area, I stop the robot for around 2 seconds and I will continue it. Move on to the next goal. So the first point is around here, and the second point is around here, and the third point is around here. This scenario, I put several obstacles to mimic dynamic environment. Sorry for the shaky video. what I did here is I try to move the obstacle to disrupt the movement of the robot. Although the obstacle is dynamic moving, the robot still can find the optimal route to achieve the goal. Okay, I will make it fast. You can see here, I try to move the chair, and the robot in real time will generate a new planning to avoid the obstacle. And here too, I try to move the chairs too. It will move to goes to first point again. And the blue region in here, it's the pipelining that robot must not to run for it. So yeah, I think that's all from me. For the conclusion, disinfectant robot has successfully deployed for around 3 hours with UV light on. And the second is a phased-in algorithm successfully implemented and can find optimal route for the robot even in dynamic obstacle. Thank you, Bu Triarti.
Thank you for your interesting presentation, Chris. And now I will invite Pak Harya Damar to ask question.
Thank you, Bu Triarti, and thank you, Pak Chris, for the nice presentation. It's the robot is very nice. Maybe unfortunately, I'm not really an expert in this area, so I'm sorry if my questions maybe sounds like a full questions or something like that. Okay. First of all, the robot, it's supposed to spray disinfectant and also what do you call it? Put a UV light on, right?
Yeah.
What is the maximum distance of a UV light for certain objects and to be quite optimum to work? I mean, is there a certain maximum distance in meters maybe, or because if it is too far, then I don't think it will be quite effective.
Yeah, that's right. Honestly, we are not focused on the UVC research itself, but we are just refresh it from another paper and product that has been launched. For example, we take the Philip UVC as our reference. So within 24 watt for the UVC light itself, and the room size of 20 meter square, it will need around 30 minutes to disinfect the room, and it's around 2.5 meters between the wall. And what we have here, we have 144 watt. We have 4 UV light with its 36 watt its light, and with those robot, our disinfectant, our robot can disinfect a room around 5 minutes with 20 meters square.
Okay. So thank you for the answers. But basically, my curiosity is about what I understand. When you try to disinfectant things with UV light, it should be in a stable condition. Let's say like you put something inside the UV light box, and then you will keep the UV light on maybe for 1 minute or maybe 10 minutes. While with your robot, the UV light will move. It will move. Now, my main question is actually, do you really think it will be effective? I mean, is it really important to have that UV light on your robot, or maybe you can just replace it with disinfectant liquid, because it's moving. While what I understand, the basic concept of UV light sterilization is actually you have to stay and then you maintain the UV light at certain for certain times without moving. Now, if you move it, do you really think it will be quite effective, or then it will be ineffective and inefficient? That's actually my point. It's nice to have that UV light on your robot, but do you really think it will be effective?
Okay, we have another algorithm for that. Just think about our usage in our campus. We have a lot of room in there. So there is an algorithm that will when the robot achieve the room A, example the room A, it will stop for maybe 5 minutes or 10 minutes to disinfect the room, and then we'll push to another room for that. So we can program in it. We can set the time and we can set the what.
Yeah. So I think it will be better. Let's say if you it's now you can actually your robot can detect obstacles and then it will reroute. But it will be even better if the robot can actually recognize certain things, and then when it recognizes certain things that needs to be disinfected using UV, then it will stop. It will put more time in front of that particular items and put the UV ray, the UV light longer, and then after it finishes, then it starts to move again. Because maybe that will be an extra algorithm, but I think you should be able to do that because you can recognize things. You have the LiDAR thing. You have the LiDAR. The LiDAR will help you to recognize things, and then when it detects this particular item needs to be disinfected using UV light, then it will stop. It will stop in front of that particular things, and then put more time. I think that's all, Bu Triarti. I think the robot. I just this is not a question. Just wonder how much does it cost to build the robot? Is it because I don't know the technology, but what I know LiDAR is quite expensive. Yeah. So that's all. Maybe so if you want to do mass production, maybe you should consider or try to find better, cheaper technology to help.
Yeah, thank you, Pak Harya, for the feedback and the input for Christian group.
Thank you.
Thank you, Chris, and thank you, Pak Harya. We will go to the next presenter. That will be Yongki Felix. So I will invite Yongki Felix for presentation.
Kedengeran ya Bu ya suaranya?
Ya, oke.
May I start? Boleh mulai ya?
Yeah, you can share the screen.
Okay, let me share my screen.
You have 8 minutes to present your research work. Okay.
Is it already shown, my presentation?
Yeah.
Okay, cool. First of all, good afternoon, lecturers and audience. My name is Yongki Felix Christian. I'm a mechatronics student. Thank you for your time today to hearing my presentation. It's been an honor to present it here in SGU Symposium. Today I want to share to you guys about my project, which is also my thesis. My thesis title itself is mung beans quality detection using machine vision. In this presentation, I will explain about my objective, as well as a little bit of my background of making this project. And next section, I will also explain about my research method and machine design. I also will present the result of this thesis. But before I come into explaining my thesis, allow me to briefly explain about my background of choosing this project of thesis. So basically, I got the inspiration of this thesis actually from my family business that run a pastry store. So they made a pastry and have a mung bean stuffing inside of it. And every day they need to wash and filter the beans every day, since there's a lot of bad beans that they bought from the market. So they need to maintain the quality of the beans itself by manually. So I was wondering, is there actually a machine that can help filter these beans? So maybe it's helping not only my family business, but also other business in Indonesia. So I did some research and I found out that actually Indonesia, we know as an agriculture country, 30% of the worker in Indonesia is actually working in agriculture sector. This data, I took it from the Badan Pusat Statistika of Indonesia on 2020. And they said that pertanian have 29.76% and ranked number 1, and have a quite gap to the number 2, which is the perdagangan that only achieved 19%. The second fact that I also find is actually mung bean is the second largest export value after corn in Indonesia. So I think in this sector, especially in the mung beans, have a huge potential to develop itself. But the problem that I found, mostly they're still using the conventional method, and we know mostly manual sorting and grading are time consuming and also inconsistent, right? So I found out another research that I took from the Center for Strategic and International Studies of Indonesia. They did some research on the use of technology from 500 companies in 2018, and they found out only 7% of the company realized about transforming to Industry 4.0. And out of that 500, only 27% of the company still use the automation. And the main problem is actually this company fact is the fact that they need to spend a huge amount of money to implementing Industry 4.0 and to develop industry grade machine. It also required a high-end component, right? And the other problem is actually lack of skills and human resource in the technology sector. That's why still not many machines that have been developed in Indonesia. Anyway, this background led to my goal of this project, which is develop an object detection, program that able to classify between a good beans and bad beans. And I also tried to make the mini prototype of the machine to just support this object detection. And the method that I'm using here is by using the OpenCV or machine vision. I already tried like machine learning like YOLO also, but I think for this case, I think after I'm testing several things, I think here OpenCV is the the suitable method that I'm using. And this is the pin types that I'm testing. I divided to 3 categories: the yellow beans and the cracked peel beans. It can be categorized as the bad beans and the good beans, and the last thing is of course the good beans itself. And the machine vision method, and mainly for my project also, is the first thing is I'm doing the image thresholding to find the binary image from the camera. And then I did some pre-processing from the image thresholding, which is dilation and erosion. And then I can find the counter for each of the pins. After I find the counter of the pins, I can calculate the pin center to find the coordinate for each of the pin. And lastly, I can draw the bounding poses or circle for each of the pins. This is what I mean by doing the dilation and erosion. The left side is actually the raw image, or sorry, the binary image from the image thresholding. And this is the first time of dilation and erosion. We can see that the noise is already removed. And this is the third time of doing the dilation and erosion. We can see here it's a much more better binary image, so it's much more easier also to develop with this kind of binary image. After that, for the find the binary image, I also need to find the value of each of the bins, so I can eliminate other colors or other unwanted material. So this is the result after I'm doing the testing and taking sampling data of each of the bins. This is my prototype design for the machine. It's actually just a conveyor, and above it there is a bracket for the camera as well as the ring light, and also a feeder for the bins itself. And for the ejector system, you can see there it's basically made from 3D printing, and each of the lane have a gate. This gate connected to a solenoid, and the solenoid is the one who responsible to open and close the gate. So this is the ejector system to eject the bad bins. Before I come into explaining my result, so I will explain the method that I use. So I'm 30 times data taking for each of the experiment and bins type, since there is 3 types of the bins, and I'm testing it on the static and also in the moving condition of the conveyor. And the experiment that conducted, the first thing is one type bins for single lane test. So I test, since in my project there is 6 lane for the ejector system, so I test each of the lane to test the consistency of each of the pin. The lane. And then the second one is with using one type bins for all lanes together. And the last thing is by using all the lanes with a mixed bin, so with a good bin and also with a bad bin. Now, lastly, we came up to the result. This is for the OpenCV result. Actually, I test with the same method for the YOLO and for other method, but this is, I think, the best one for the fine counter. We can see there that actually it quite achieve a high accuracy, especially in yellow beans that achieve 100% of accuracy, because it's more contrast rather than the good beans. So I think it's much more easier to detect the yellow beans itself. And the lowest accuracy is on the crack or peeled beans, since sometimes the beans itself, since it's too bright, so it's sometimes it's overexposure, so the computer sometimes is also confused whether is it actually a noise, a light, or is it actually a beans. That's why the crack or peeled beans have a little bit much lower accuracy. And we can see also that in the moving condition, the accuracy actually also a little bit low rather than the static, because here I'm also using we know that machine vision require a good camera and good equipment, and here since it's only a proof of concept, so I'm unable to use a industrial grade machine or industrial grade equipment. But I think if we improve that, the accuracy will be much more better. We can also see here with the result in the mixed beans, you can see that the overall accuracy in static is achieved 91%, and in the moving condition it achieved 90%. This is a little bit video of the program that I tried to develop. Okay. As the conveyor moving, the beans is coming. Sorry. And there is the number of beans. It's automatically detected. The right side, the most right, is the bad beans, and the other rest is the good beans. So it automatically detect the good beans and the bad beans, and the number of blob is actually represent the number of bean inside in the one frame of it. So lastly, I think I believe that this sector has a lot potential to develop. This is still so early developing, and as I explained before, as an agriculture country, this sector have a huge and have a lot thing to improve. So I hope in the future there is a lot of people that do some research on this area, so it will help a lot of people in agriculture sector, and I think it will also improve Indonesia sector industry. So I think that's all from me. Thank you so much for listening, and if you have any question, I will
Yeah. Thank you, Yongki. Now I will invite Pak Harya Damar. Pak Harya, now we have 2 reviewers, so I will invite you to ask only one question.
Oh, okay, that's good. It's even better if I don't have to ask any questions. Okay, just one question. Thank you, Yongki, for the presentation. It's about your test because what you show in your video, you put the bin in the lineup position. Did you try to, let's say, like mix them up? I mean, in your video, this lineup, and there's quite a distance between those bins. But did you also try to mix them up? Let's say, like, yeah.
Yep. Okay, thank you. So I also tried it for mix it up. So of course there's also some confusion in the computer since the bins is stuck with each other. So
yeah,
that's why I'm trying to prevent it by using lane. So when I have the video, but I think there's not enough times.
Yeah.
But for the feeder, I already determined the lane. So every time it's
so
it's already in
okay.
lane.
So in your hardware design, it will make sure that once the bin is being fed into the machine, that it will come up in a lined up position. So it will. Okay, that's good. Okay, that's it. Thank you.
Thank you, Pak Haryo. Now I will invite Bu Yunita.
Okay, thank you. Okay, it's still related to Pak Harya questions because in my imagination, no, because I know the product of your family, what is industry. I just imagine that, let's say one sack of bean is dropped. So it's randomly, of course, fall in the I don't know, in the basket maybe. So based on your based on your result now, actually I'm interested in the next improvement, so that it can really be used by your family's industry. So in your calculation, how many more stages are your research ready to apply?
Oh, I think it's still far from industrial ready, because the first thing in this my thesis, I mainly focus on the program, so I doesn't improve a lot with the machine itself. So I think if we want to improve it, first thing I think it requires still a better camera. So because the main thing of this object detection is of course the camera and the lighting itself. So it's the first thing to develop, and the second thing is how to improve to maintain the. We know that for now I'm only using like 500 gram of beans, but later on if we want to industrial ready, of course it's like 5 kilo or even in 100 kilo or so. I think the thing that need to develop is the feeder itself, how to maintain it in remain it in the same lane, and to have a gap each of the bin, so the camera can handle it one by one, and also can eject it one by one also, so there is no bins that eject correctly or wrongly. I think that's the things that we need to develop.
Yeah, okay. Thank you, Yongki.
Thank you, Yunita.
Thank you, Yongki, for the presentation, and thank you, Bu Yunita and Pa Harya for the reviewer. And then I will invite Pa Gunawan Bondan for present the research.
Thank you. So first of all, I'd like to share my screen. Okay. Okay, so does everyone can see my slide right now?
Yes, it's okay.
Yeah, okay.
Yeah.
Thank you. So good afternoon, everyone. So first of all, I'd like to do presentation about my thesis work and my research. It's a human embryo development annotation for cell detection using convolutional neural network. And my name, first of all, my name is Gunawan Bondan Nardono, and I'm from the IT department. And first of all, I'd like to introduce some background about the work of my thesis. So the World Health Organization has estimated that around 48 million or 15% of productive couples are experiencing infertility. So infertility is actually a condition where male or female, or could be both, does not have the condition to have a child. So then one of the solution is through an in vitro fertilization, and it is an external fertilization process. And the procedure itself is quite expensive, and with the uncertainty of success probability with around 30% compared to the natural fertilization process. So during the process, there is one step. One of the steps is for embryologists to observe the embryo manually, and if there are multiple embryo available at time, it might take some time. And I will explain an illustration about the cycle of IVF. So an IVF cycle is usually started with the stimulation of ovaries. So then the woman could produce multiple eggs at a time, and those eggs will be fertilized. And under under around 5 to 6 days, those eggs will be cultured and will be transferred to single embryo transfer, and the rest of the embryo will be kept frozen until the pregnancy is achieved. So the data for embryo that is developing under 120 hours, or sometimes could be 144 hours. It's all split under 14 categories started from after the sperm injection, if we call it T1, and then cell split 2, cell split 3, and so on up to the stage where the embryo cell is compacted with and it's called compaction and morula and blastocyst stages. And the approach of my thesis work is to utilize CNN. It's a convolutional neural network that is able to determine an image and classify those images. And under neural network, it is set under with nodes or neuron, and those node or neuron will be paired with weight and determine the differences with a mathematical approach. So it will be able to classify images. So the CNN itself is a neural network that is applicable to do an image and video analysis. So the objective is actually to utilize CNN architecture to get the highest yield accuracy, and also develop an model that is capable to do embryo annotation up from the post-ICSI or sperm injection to the blastocyst stages. So previously there are multiple research. One of those is done by Lewis on 2020 by using 4 cell stages, which is the embryo from day 2. And the model that he is using is Inception version 3 and medical image classification proposed by Lee on 2014, and with the highest accuracy yield of 74%. And also there is research by Malmstenet on 2019 with the use of 4 cell stages, and he is using a random image rotation or data augmentation, and surprisingly he got 90% accuracy. So the approach of the thesis work is to utilize so the original data is actually a video data of embryo, which captured by dedicated machine and produce a video, time-lapse video, and those time-lapse video will be split into images and will be fed into a sequential API. And under the sequential API, it will receive input and do a transfer learning process and have a dropout layer, dense layer, and then finally build the model. And those process will be repeated for multiple times using different hyperparameter and pre-trained model. So on the final model, we can train the model for a further or longer time. So
excuse me, Gunawan, can you speed up your presentation?
Okay, sure.
Time is almost up.
Okay, so the method is using this is the sample of the machine that is being used, and the data of embryo is this one is a sample of the embryo images, and I will go on. And the data that I'm being used is around 15,000 images in the split of T1 up to the expanded blastocyst. And I compare 6 pre-trained model with different parameter and found out that this hyperparameter is work best on these 9 condition. So then I use one of the model, the EfficientNet B6, because it have the highest accuracy compared to the other, and using Adam MS grade and 1 times 10 to the power of -3 learning rate, and the data augmentation is actually does not helpful in my case. And the final product, I have a model that capable to do embryo annotation with the accuracy of 67.68%. So this is some of the result outcome which already conclude with the number 8 with the highest accuracy. So for the next recommendation for the thesis work is actually for the conclusion actually, so the CNN is applicable to do the embryo classification up to the expanded blastocyst, and compared to the some of the previous study of 4 classes, my model is applicable to do 14 classes classification, and yet it have some kind of lower accuracy rate. And for the next project, I would like to do some more data extraction for the embryo and use some other data set like the abnormal embryo, and introduce a concept of RNN, recurrent neural network, to have self-generated narrative for embryo development. So the model that is being used is fed into a machine, so then the machine will produce a result. So then embryologists thus will then simplify to validate and do adjustment of the classification of embryo. And this is the sample of the outcome from the model, and it is applicable to do most of the event. And I think that's it for my presentation. Thank you.
Okay, thank you, Gunawan. Now I will invite Pak Harya for asking one question, please.
Thank you, Bu Triarti, and thank you, Pak Gunawan, for the presentation. My question is because you mentioned about optimized CNN. What I see from your presentation, what is being explored for optimization is the optimizer function and also the learning rate. Yes. Are those 2 parameters that is being optimized?
Yeah, and also the pre-trained model. So actually, I do training of up to 80 different parameter, and I conclude those on that the EfficientNet B6 with the Adam MS grade and 1 times 10 to the power of -3 will yield the better result compared to the other.
Is it a brute force approach that you use for?
Yes, actually, yeah.
Okay, yeah. So maybe I just have one suggestions because there are a lot of optimization algorithm that you can use. Something like GA, maybe genetic algorithm, and then you can actually set all the parameters that you want to explore, and then you set the function, the objective function that you would like to achieve, which is usually the accuracy, and then you can just set it, and you can do this with Python. It is quite simple. There's a lot of code that you can use for this. So maybe for the future, you can other than doing a brute force approach to find the most optimum parameter settings, then you can actually put on some optimization algorithm which will do it automatically for you. So that's maybe that's just a suggestion for your future works. Thank you. It's a good job.
Thank you.
Thank you, Pak Harya. Now I will invite Bu Yunita.
Okay. Thank you. I only have a short question regarding what is the continuation of this research, because this seems like a long project. Yeah, so approximately ready to use if the accuracy reach how many percent, Gunawan Bondan?
Yeah, thank you for the question. So actually, it's right now we are still conducting research with this. So I conduct research with one of the IVF clinic in Indonesia, and I join with the research team. And for now, the most, I think, somewhere around 70% will be an optimal accuracy to conduct an initial usage. But then again, it will still be need to be supervised by embryologists.
So we don't have to wait until, for example, more than 90%.
Well, since we also use the capability of the embryologist, so I think 70% is sufficient.
Yeah, okay. Thank you, Gunawan. Thank you, Bu Triarti.
Thank you, Bu Yudita. Okay, thank you, Gunawan, Pak Harya, and Bu Yunita. Now I will invite the next presenter, Tony Wiguna, to deliver your presentation.
Okay, thank you, Bu Arti.
Okay.
Okay, let me share screen first.
8 minutes ya, Tony.
Okay. Okay, so good afternoon, everyone. So my name is Tony Wiguna, and I'm from Industrial Engineering. So today I would like to present my thesis research. It's about designing hand washer sink for primary students from ergonomic perspective. So for my presentation outline, there will be introduction, literature review, research methodology, results and discussion, and conclusions and recommendations. And chapter 1, introduction. For the background, since the shocking outbreak of COVID-19, everyone in the world has prioritized their hygiene in every activity that they have done. And washing hands properly is very important. What's more, while you are in the public toilet. Hygiene of the sink in public area is quite concerning as there are lots of people who use it in one day. And children need to wash their hands often. What's more, children used to have lots of activities every day and they need to keep their cleanliness in order not to get infected by the virus. If the sink is hard to reach by the children, they might be lazy to wash their hands as it needs more effort to just wash their hands. And it is important to measure the height of the sink in order for the children to be able to use it properly and easily. It will also help the children's safety while washing their hands. Next, an automated hand washer sink has been developed by Theodorus Krisnayanto, who studied mechatronics in batch 2016. And problem occurred in the existing prototype is due to the position of the sink is too low for the user and traffic may occur while washing hands. And for the objectives of this research are evaluating of existing prototype, evaluating the task analysis of primary students' behavior, propose improvement, reduce the time needed while using the automated hand washer sink, and improve the height of the sink based on ergonomic approach. And for the research scope, this research will focus on the height of the sink based on ergonomic approach and time needed while washing hands. And the limitations, there will be no sensors applied on the proposed prototype. For the literature review, there are ergonomics, physical ergonomics, user satisfaction, task analysis, ergonomic design, and technomatic check simulation. And in the physical ergonomics, there are anthropometric measurement, biomechanical, musculoskeletal disorder, or M.Sc. And for the ergonomic design, there are safety, sitting operator, hygiene, aesthetic design, and reliability. For the research methodology, so I used the MADV method. So in the development process, there are problem identification and literature review. For the measure, there are collecting data and process data. For the analyze, there are task analysis and gap analysis. In the design, there are improved design. And in verify, there are evaluation and implementation. For the results and discussion, for the problem identification, due to low height of the sink, bending occur on the user while washing hands, and traffic will occur due to homing process. And we move on to the data collection. This shows the existing prototype overview. And this figure shows the deficiency occurs in the existing prototype. The left side of the figures shows that the height of the sink is based on the waist of the user, and in the right side, when the user is using the hand washer sink, bending occur as the height of the sink is only in the waist of the user. And where's the data collection, the standing operator, it shows the example of different example of work. So there are three examples, which is precision work, light work, and heavy work. So washing hands is classified as a light work activity. So the height of the sink should be approximately 5 centimeter below the elbow height of the user. And for the data collection, the anthropometry data of elbow and body height. So I use 2 dimensions here, which is body height and elbow height with the age of 7 to 12 with 5, 50, and 95 percentile. And I get this data is from the anthropometryindonesia.org. And next is the ideal position while washing hands. The ideal positions of the washing hands need to be 0 to 10 degree of bending. It still can be categorized as an ideal position and still acceptable. And the height of the sink need to be based on the elbow height of the user. So I calculate for the optimal sink height is from calculating the mean of the percentile of the anthropometry data. So the first optimal height is 66.8, the second optimal height is 77.7, and the third optimal height is 88.6. And for body height of 110.97 is 66.8, for 125.30 body height is 77.7, and for 139.63 is 8.6. And for the task analysis for washing hands in regular hand washer sink, it needs in total of 36 seconds if you are washing hands regularly. And for the washing hands in existed automated hand washer sink, it needs a total of 74 to 79 seconds, which is a lot of waste of time, is due to the homing process. The homing process occur needs 30 seconds for itself, which is a waste of time. And for the gap analysis, for the current situation, bending occur while washing hands for the user, and the desired situation, the position of the body should be straight or in ideal position. And for the action plan, the position of the sink need to be higher. And for number 2, the current situation, waiting time is 30 seconds, and the desired situation, the waiting time should be as short as possible. And for the action plan, the formula and algorithm need to be changed. So this is the improved design, the design justification. So I use the 3 optimal button for the prototype, which is 66, 77, and 88. So for the safety factor, I used a barrier here to prevent the water basin from moving, and also use double shaft in order to maintain the reliability of the prototype. And I use a support here to prevent the prototype from falling apart. And I use the evaluation using the simulation with Jack. So the first user I use for the height, the third optimal height, which is the 139 centimeter, and the second user I use the second optimal height, which is the 125 centimeter. So, and when they are using the height, the sink height of the third optimal sink height, which is the 88.6, the user with a body height of 139, as you can see here, no bending occur when the user is using the hand washer sink, and the second user also no bending occur here as it is using the hand washer sink. And what if the user with 135 centimeter use the height of 77.7, and bending occur here as 50 degree of bending occur, and it is not classified as ideal position, as the ideal position is only from 0 to 10 degree. And this is the time report from the Jack simulation. So for the first user, in total there are 29 seconds, and for the second user.
Excuse me, Tony, can you speed up your presentation?
Okay. And in total, for 2 users, it needs 59 seconds. So this is a video of my proposed prototype. So the hand washer sink is available with 3 buttons. And the first button has an optimal height of 66.8, and the second button has optimal height of 77.7, and the third button has optimal height of 88.6. So I use a user with height of 139 centimeter, and she used the third button with optimal height of 88.6. And the faucet and soap is also automatic. No mating occur on the user while using the sink. Okay, that's all. Thank you for watching. Next is the conclusion and recommendation. For the conclusion, the existing automated hand washer sink has been improved based on ergonomic approach, as there will be no bending occur while using the new hand washer sink, and homing process has been removed totally to avoid waste of time and to increase the effectiveness and efficiency of the automated hand washer sink. And the efficiency of the time frequency has been improved from 74 to 79 seconds to 29 seconds. This shows the improvement of time efficiency of 36 to 39%. And the difference between regular existing and new automated hand washer sink. For the regular hand washer sink, it has automated faucet and soap, while the existing automated hand washer sink, it has automated faucet, soap, adjustable, and portable, while the new automated hand washer sink, it has automated faucet, soap, adjustable, portable, ergonomic, and it is suitable for kids. And for the recommendation, based on the design of the new proposed hand washer sink, the aesthetic of the design can be improved. And if the design of the new proposed automated hand washer sink has been improved with more budget, there will be a lot of customers who would like to buy this product. Then for further research, keep away the electrical secret for the user to guarantee the safety of the user. Thank you for listening.
Okay, thank you, Tony, for the presentation. Now I will invite Bu Yunita to ask one question, please.
Okay, Tony, nice project.
Thank you, Miss.
Yeah, because it's very useful, especially when the elementary school students have come back to study in the school.
Yes.
So actually, I'm interested in where we have to put the electric components.
The electrical components, I put in the top of the prototype, but I use like something of board to prevent from the children to playing with it.
And then how about rainy season, for example?
Yeah, I already covered the electrical circuit with the board, so it will not. So the rain cannot go in through it.
Okay, thank you.
Thank you, Bu.
Thank you, Bu Yunita. I will invite Pak Harya.
Thank you. I think it's a very interesting project, and you definitely have made some improvement to the previous or to the existing prototype. Just one question, Tony. The button that you use to move the level of the sink.
Yes.
Is it a touchless one, or is it currently a touchless one, or is it something that you have to press?
It's something that you have to press.
Now, I think that's another suggestion, because all of it's a touchless. Then the button is still, you have a point of touch at this 3 different buttons. So maybe for further improvement, you have to change that to a sensor or touchless button, like the one we have in the parking ticket machine and so on and so forth. So because now everything is touchless, the soap is touchless, the water tap is touchless, but the button is, you still have to touch it. So maybe another improvement that you have to incorporate in the future. So it's totally touchless sink. Maybe that's all. I think my suggestion. I think, but anyway, it's a very good improvement to existing prototype.
Okay, thank you, Pak Harya.
Thank you, Pak Harya, for the feedback. It's very interesting, and yeah, you are right. Thank you, Tony, for your presentation. Now we will go to the last presenter.
Okay, thank you.
I will invite Pak Dwianto Nugroho.
Yeah. Oh, sorry. Okay. Hello, gentlemen.
Yeah.
Okay.
You may
Let
start
me
the share screen, the slide.
Yeah, wait. Can you see on your computer?
Yes. In
Okay.
slideshow, please. Yeah, that's better.
Okay. Thank you, Bu Arti and gentlemen, for the opportunity. Let's introduce myself. My name is Dwianto Nugroho on behalf of Group 2 from the regular class for bridging program United Tractors and then SGU University. I want to explain regarding our paper, Improving Waste Management System in Indonesia, Leading Heavy Equipment Distributor Company. This is a study at Industrial Development Center in East Jakarta. This is our lecturer, Pak Adit. This is the overview from introduction until the reference. Yeah, I will go fast. And this is for the introduction for the what was the generation rate. Looking for the area, the South Asia in the 2016 until 2050 is higher. Yeah, for the what was generation rate. And also for the Indonesian was the head in the 2019 in the Jakarta province got increasing until 6% for the total in Indonesia until 200 etc. And then on the 2020 also increasing until 8% from the total of the total Indonesian Western head 2020. Yeah, this is source from the Sistem Informasi Pengelolaan Sampah Nasional. This is wasted component from during the 2019 until 2020, mostly coming from the left loafers, twig, paperboard, almost 14%. Yeah, and then we have also until the paper, metal, fabric, rubber, glass, and the others. And then special from the DKI Jakarta in the 2019, especially in the DKI Jakarta, that they have mostly industrial company on there. This is contribute until 40% for the total in Jakarta from the 2019 until 2020. This is the background. This is in PPI. The for what wet, yeah, this is for the hazard waste in the tonnage in the 2019 until 2020 for also for the domestic waste. And then for the junk, we have also the data in our PPA Cakung in our area last 6 months in the produce until average 89.02 meter cubic per month. So this is a huge number for the waste. This is for the background for the general waste flow process at our Industrial Development Center Cakung at PPA Cakung. Number 1 is for the self-disposal, the collecting process point until the packing and the sending to the landfill. This is the sample photograph. And then for the research question and then research objective is how to improve our waste management system at Industrial Development Center in Jakarta. And then research objective is designing improved waste management system at Industrial Development Center at Jakarta to reduce volume of the waste on the main disposal area. This is our scope and limitation. Only for our PPA Cakung, for our office building, warehouse building, and also workshop building. This is all of in the Cakung area in the East Jakarta. This is the location. And then this is for the literature. Yeah. I will go too fast. And then for the methodology, this is the simple methodology. We have the complying the simulation. We have the problem and try to identify, and we have also the data and try to make the identification using the simulation by using PowerSim. If the simulation is okay, not okay, they will back to the another option, and if the simulation is okay, they will try to the analyze and they make the final solution, something like that for the our methodology. This is for the research and analysis. Before, for the actual, we have in the PPA Cakung the total of employee until 2,800%, with the volume of waste general person is 1.2 liter per day. And then truck capacity, we have the 6 meter cubic, and the truck only 1, and the frequency or garbage collection from the TPS to TPA every 3 days. And the TPS volume accumulate constantly, no empty condition in this condition. So looking for the graph, this is looking the increase, yeah. So we try to another option for this is option 1 for the model 2. Try to request garbage collection time every 3 days. And then the rocket TPS and the TPA capacities are large because all of the waste produced in the dispute of the TPA. And then the TPS is the total 6.72 meter cubic, and the TPA final until 94.08 meter cubic. Number of truck only 2, and then frequency or get back from the TPS to the TPA every 3 days. This is the simulation, the graph simulation. And then we have the option 2. The proposed improvement for in here, the required garbage collection time can be extended every 4 days, and then the capacity of the required TPS and TPA can be reduced because there is a distribution of waste that temporary accommodation, and then the TPS distribute to the collector for recycling and recovery to make compost on biofuel. And then looking for that also the number of truck only 1. This is also we have can saving for the fee cost every month, yeah, like the fuel for the driver cost also. So we choose this one, and then looking for the simulation, this is the best way right now. And then conclusion, as option number 2 as our improvement condition as dynamic model of the integrated waste management system at the PPA at Jakarta. The simulation of model option 3, depend of the user interest for the user who are the engine, the transport sector, frequency of the pickup, and then the type of the carrier related to the volume of the transportation are driving variable to the need to be simulated, where the user and the insert the volume and the landfill to needs to provide like this. This is also still only for the what is it on the paper, yeah. We still need the another option to get the best way for the to implement our office right now. This is the reference for the last. Yeah, thank you, Bu Arti. Maybe I'm back for the chairman. Thank you.
Yeah, thank you, Pak Dwianto, for the presentation. Now I will invite Bu Yunita to ask question.
Yeah, okay. Thank you, Bu Triarti and Pak Dwianto. This is a very interesting problems, and actually this is the first time I've heard a presentation about waste management system in industrial areas. So I only want to know about the improvement. Approximately until how many percents it can be increased. I mean about the efficiency.
Yeah, this is the base simulation is the increase, the increase, but we still need to discuss again with our management to implement again. because we still what is it to support us to our research and analysis in our paper like this.
And then what factors that can affect the process to increase the efficiency?
Sorry?
What factors can affect the improvement of the efficiency when we need to increase? I mean, what factors?
Yeah, actually the some employee also they produce the garbage, yeah. So back to the personnel, they can be reduced not making the garbage as they can, and also genetic factor as the green company also make the how to simulation and also to make the handling the waste management better and better, something like that.
Okay. The last question: how about local government policies, Pak, about the waste management system?
Yeah, we should together to work together with our local government, not only for our company. Yeah, we need the others participant like the local government to support us to reduce also the garbage.
Okay, thank you, Pak Dwianto. Thank you, Bu Arti.
Thank you.
Thank you, Bu Yunita. I will invite Pak Harya to ask question.
Thank you. This is actually definitely is not my expertise, but just one questions because you, Pak Dwianto, your presentation, your work is based on data, and do you think this option, the simulation that you're building, will still be relevant for current condition? Because what I know, during the pandemic, maybe the nature of waste production is also changing. So yeah, so do you think this will still be relevant to current condition?
Yeah, thank you, Pak Harya. This is we take the data is before the pandemic, yeah. Before the pandemic, and then the volume of the garbage is increased. Actually, right now, after we have the limitation of the workers goes to the office, also the almost decrease for the waste management for the garbage, yeah. So I think this is also still related, still in connection. When we have working in the normal condition, all of the people come to the office. This will be useful, yeah. We can implement that, and also I know that this is still not fixed. We still receive many advice from another to implement the best way in our office at Kakung, Pak.
Yeah. Okay, thank you. So maybe that's just my questions only that, and then just as suggestions, because maybe things is not going to be like they were before. So maybe the productions of household waste will become larger in the future, and then the production of waste in the industrial will maybe decrease. Yeah. So it will be interesting actually if you using new data during the pandemic, maybe data in mid to 2020 till mid 2021, and then you can actually develop another model, another options for waste management. Maybe that's only a suggestion for future work, Pak. But anyway, thank you very much. It's very interesting. Sure. I hope this can be implemented in the real world. Thank you.
Yeah. Thank you, Pak Harya. Thank you, Pak Bu Yunita. Thank you, Pak Dwianto, for the presentation. The waste management is not a lot of people willing to do this kind of research. Okay. With the end of the presentation from Pak Dwianto Nugroho, this will end the SGU Symposium Day 1. And on behalf of SGU Symposium Committee, I would like to say thank you to Professor Dominik and Pak Harya Damar for all the review question and also the feedback. And I also want to invite all the participants to join the day 2 of SGU Symposium tomorrow, because we will have Pak Nuki Agya Utama as keynote speaker, and then we have Professor Misri Gozan from Universitas Indonesia, and then also we have Pak Professor Kuat from UGM as the inventor of genose that detect the virus corona. So stay tuned until the end of Symposium Day 2 tomorrow, because there will be a lot of door prizes waiting for all of you. So thank you and see you tomorrow. Bye.
Thank you, Bu Arti. Thank you, everyone.
Thank you,
Thank you,
Pak
Pak Harya.
Thank
Thank you,
you.
Bu Arti, Bu Yunita.
Good luck.
Thank you.
Good luck, SGU. Thank you. Stay healthy.
Ya.
Thank you, Pak Arya.
Yo, sama-sama. Terima kasih semua.
Ya, saya izin leave.
Saya juga izin leave.
See you tomorrow, Bapak Ibu.
Okay.